and I will give you a short presentation which will be followed by a specific presentation from the Director of the Accelerator and Source Division, Pantaleo Raimondi, and the Director of Research, Harvard Reichert and Jean Susini. So first of all, just a technical detail. During the webinar that we hope is going to be interesting for you and will last roughly 40 minutes, you can send us all kinds of questions in the using the question and answer box. So Delphine, who's going to help us during the webinar, will collect these questions, and then we will try to give grouped answer on the different arguments that you may raise at the end of the webinar. So having said that, I note that we are getting close to 1,000 people. So it's probably now time to start. So I will share my screen with you and start my introductory presentation. Which is here. And as you can see, what we want to share with you is the status of the EBS storage ring commissioning and the restart of the beamlines. In fact, we are at the end of a shutdown that started in December of 2018 with the objective of restarting our user service mode in August, at the end of August of 2020, of this year, so in few months from now. And to give you, therefore, a view of what has been going on during this long shutdown, and in particular, the progress in the commissioning of a new storage ring, the EBS storage ring, that in principle should provide you with very nice, unprecedented opportunities to carry out your X-ray science here at the ESRF. So what you see here is the master plan that was developed in 2015, showing the work associated with this EBS program, the delivery of the new storage ring, and the restart of USM. Until end of December 2018, all the work was carried out in parallel to the user service mode. Then a long shutdown started, and it took roughly 11 months to dismount the old storage ring and install the new one. And in fact, according to the schedule and within schedule, at the end of November of 2019, we indeed started the commissioning of the new storage ring. And the plan also foresee that we would start the commissioning of the beamline and the restart of the beamline at the beginning of March of this year. And in the middle of March, as everywhere else in the world, we have been locked down as a consequence of the pandemic COVID-19. We are now here at the beginning of June, and as you can see, the initial plan of starting USM at the beginning of September of this year is still there, and we will do all our best to maintain that date. So, a very important message to you. On 14th of March of 2020, so just before the lockdown, the new EBS storage ring has achieved the parameters that are necessary, that were planned to be necessary in order to restart USM at the end of August. So 5 months ahead of schedule, the EBS storage ring is there, and this is a snapshot of the situation on Saturday, March 14, the last day before the COVID-19 induced lockdown. The ESRF storage ring was operational. As you can see, 200 milliamps, topping up, very stable beam, record-breaking horizontal emittance. And of course, all kinds of commissioning processes are still going in terms of vacuum conditioning, consolidation of the systems, and so on. But Pantaleo will give you much more information in his presentation right after mine. Then, on 14th of March, as we all know, through this world, we have been hit by this COVID-19 outbreak, and with this unprecedented effect on our life and also on the operation of the ESRF. So following the French government announcement, because we are in France, on measures to be imposed to overcome the pandemic, the ESRF site has been closed from the 16th of March until the 11th of May. During this period, we implemented a continuity plan for pandemic. Starting from the 12th of May, we have restarted activities, and again, in line with the guidelines, the measures and the procedures requested by the French government, we are implementing a gradual restart during this period. So, to summarize, from 16th of March to 11th of May, less than 10 people were on site. We were closed, implementing a continuity plan for pandemic, and most of the ESRF staff continue to work using teleworking means. During this period, we have revised our strategy in view of a restart on the 12th of May, and the objectives that are now driving the work here at the ESRF, following all the elements imposed by the lockdown, is first of all to ensure that people coming back to work at the ESRF can work in safe working conditions. And the other strategic objective that overwhelms all other activities here on the facility is to give you back, the users of the ESRF, our service as planned on the 25th of August. So our objective is to be able on the 25th of August to go back to USM with a maximum number of beamlines available for users. We have restarted on the 12th of May, and following again the French prescription, we have a first wave that lasted until 1st of June, in which we learn to go back to work under these new circumstances, and we resume gradually the storage ring commissioning and the beamline restart. But also, we equipped ourselves in order to identify those instruments that can contribute to COVID-19 research, and you will something about it. During this period, about 100 people have been on site, so basically during the last 2 weeks. This allowed us to resume the operation of the storage ring. You can see it here very nicely. This was yesterday, Monday, June 1st at noon, 200 milliamps, very stable operation, still doing vacuum conditioning, but nevertheless, we reach a very nice lifetime of about 18 hours and very good vertical and horizontal emittances. But also what you can see here is that many beamlines are green. Indeed, many beamlines are now restarting, taking beam and preparing themselves for users mode at the end of August. I also want to note that some of them are doing, as we speak, COVID-19 research. These are 3 macromolecular crystallography beamline and a bioimaging experiment on BM5. And you will see some very beautiful data that are coming out from BM5 in Harald's talk. We are also carrying out cryo-EM experiments. So what about the next month? So until the 10th of July, which is the date in which we hope this sanitary alert will end in France, we'll continue this gradual increase of people on site and carry out the work according to the objective that I just said. After the 10th of July, we will still have a nice period which will be shared between a period of shutdown and a period of operation, in which we will try again to get ready to a full operation, full USM on the 25th of August. So, as you can see, we are really restarting. And just for your information, what I show here, the accelerator complex is on its way. It needs something like 1 to 2 months to really achieve optimal conditions in terms of vacuum. And again, Pantaleo will tell you more about that. And as far as the restart of the beamlines is concerned, we believe that we need something like 3 to 5 months from basically the middle of May in order to retrieve fully the program as it was planned before the virus outbreak. There's going to be changes. There's going to be changes that will be presented to you by Jean Susini in the way in which we will operate these beam lines in the next few months. In particular, basically the users period going from September 2020 until March 2021. We will implement, whenever possible, remote access on beam lines. We will give, in restarting the beam lines, highest restart priority to those beam lines which are compatible with remote access and also almost ready to go. And on that basis, the beam time allocation panels meeting that took place at the end of April continue to do their job, grading the proposals on the basis of scientific excellence, but in the final scoring, we will take also into consideration the compatibility of the proposal with remote access sample mailing. And as I mentioned, the details will be given later on. So we have been also working on science and preparing the science of the next exploitation of the ESRF with this new storage ring. I will not go into the details, but our science program is very well aligned with the Horizon Europe objectives, as well as the sustainable development goals that have been put forward by UNESCO. This is my last view graph by telling you that we are joining forces with our partners on the EPN Science Campus to restart all our capacities in order to contribute with X-ray science to the big scientific questions that this virus outbreak has put forward to all our society and to the whole world. And as I mentioned before, many experiments are going on in structural biology, in bioimaging, and in high-resolution cryo-electron microscopy. So we are restarting all these activities, and of course, there is a procedure that you can discover on our website if you have good ideas to put forward activities that are relevant to COVID-19 research at any time from now. So I want to finish with these 3 take-home messages. The first one is that new EBS storage ring is up and running with design performance. Pantaleo will tell you more about that. The date of USM restart of 25 August is maintained despite the COVID-19 pandemic. The 2022 USM period from August 2020 to March 2021 will be carried out mainly by remote user access and sample mailing procedures. And John Susini's talk will tell you more about that. The ESRF upgrade program is getting close to completion. with the phase 1 that was delivered in time and budget by 2015 and provided 20 new instruments. The new storage ring EBS is now operational and ready to provide X-rays. And so altogether, a new exciting research opportunities period is starting, and Harold will tell you more about this. So with that, I thank you very much. And we all look forward to welcome you again for exciting new science here at the ESRF. So now I stop sharing my screen to allow Pantaleo to come online. So as you have seen, it's really a new moment that is starting here at the ESRF. It's concomitant with this major challenge that we all are called to face, this virus outbreak. The data in Europe, and hopefully soon also in other parts of the world, in particular in the Americas, start to show signs that this pandemic is going under control, is maybe becoming less infective. A thought to all the people that died because of this viral attack. A thought to all the people that contributed in the hospital in maintaining fundamental services going during this 2 months lockdown in order to keep us going. And now it's time to really look at the future and hope that even in a world that has changed, we could hopefully continue to contribute to the peaceful advancement of our society. So you can see now Pantaleo's talk, and I give the floor to him. Thanks, Pantaleo.
Thank you, Francesco, for the nice introduction. So I will just go through a very quick overview of the progression of the commissioning of the new accelerator, and I hope that I will share with you some of the excitement that we had through these months that were extremely rewarding. So apart the progression on the commissioning, I will also spend a few words on where the machine is now and what we foresee to deliver to the users, and a very quick overview of some of the highlights, some achievements of the machine, and then actually I will also give you a glimpse of what we think that the machine can further do in terms of improving its performances in the near future. So as you can see from this slide on the left, this is an old screen, but we still use it from the last machine actually. And this white ellipse in the middle is the first beam that actually enters the storage ring on November 28th. There is a screen right inside the ring, and those are the real first electrons ever seen. And amazingly, when the screen has been removed, because obviously it is intercepted the beam, we could already see the beam going through almost 3 turns in the storage ring, as you can see from the right side, where you see basically the signature of the beam through all the beam position monitor that we have in the ring. We have about 320, so the vertical scale, and you see that we have readouts for 3 turns. So we actually are able to start the commissioning of the storage ring about 4 days ahead of schedule, thanks to this. On December 6th, after obviously optimization of all the orbits and so on and so forth, injection through the ring, we were able to actually store the beam. About 60 microamps were initially stored, and we had immediately all the signals, all the diagnostic available. In particular, you see on the left part, you see actually this is effective beam profile taken with our from our pinhole cameras, and we could already measure the emittance right away and the beam properties. So this was really striking. So a few days later, we were able to increase the beam current. You see now 280 microamps, and we could start to see even a decent lifetimes of the order of a few hours. And in this condition, we could already see that the vacuum was responding at the electrons, and we could start really the conditioning of the machine. On December 15 was real a magic moment, really historical, because we were also able to accumulate electrons. So basically it's relatively straightforward to inject electrons on in the ring, but it's not that straightforward once the electrons are already there to add electrons on top of that. Is because we disturb the electrons stored in the ring, and is very hard to simultaneously achieve these conditions. And as you can see from the blue line, once accumulation is achieved, you can go up in current as much as you want, say forever, or up to you get other obvious limitations. So this was really an achievement that for high energy machines was very was considered almost impossible task for fourth generation machine. And thanks to this, we were able to further increase the current, and in only 20 days from when we started, we were able to exceed 6 milliamps. And when you do the calculations, thanks to the much smaller emittance, we were able already to produce a beam that was brighter than the brightest beam ever produced by the former machine. In January, we resumed quickly operation, and you can just see the striking progression in terms of stored current. In less than 1 month, we were able to achieve more than 50 milliamps, and right at the beginning of February, more than 100 milliamps. And you can see that the injection efficiency was already exceeding 90%. When we established accumulation, I had it in the previous slide, we had only 0.8% injection efficiency. Means that for every 100 electrons that we were injecting in the ring, only 1 was effectively stored, captured. All the others were lost. So obviously extremely inefficient. And thanks to the tuning and debugging, we were able to reach almost 100% efficiency from this point of view. And as you can see, also we were able to recommission the top-up routine that give us almost constant current through in time in the ring. So Francesco has already presented this slide, and again, I want just to stress that thanks to top-up operation and the good uptime of all the equipment, we were able already to exceed more than 98% accelerator availability at the start of the beamline commissioning right on the beginning of March. So in terms of parameters, as you can see from this is a slide that actually has been presented to the all the bodies, SAC, MAC, and Council in before the start of the commissioning. We had a set of goals for all the parameters that could have allowed the subsequent restart of the other phases of the program. And as you can see, all the parameters that were meant to be achieved in order to restart the beamline commissioning were achieved 1 month ahead of schedule. All the parameters that were meant to be reached in order to safely operate in USM were reached, as Francesco mentioned, 5 months ahead of schedule. And finally, all the parameters that the final parameters that the machine can achieve once everything has been fully debugged and tuned are that were meant to be achieved by the end of 2021 are basically there. We are very hairbreadth from these parameters, so more than 1.5 months ahead of schedule. So for what concern the impact of the COVID, obviously this gave us much less time to do many things. Fortunately, as I just said, we are in a very advanced state, so we can digest many of these delays. Obviously, for the installation of the CRG sources, we could not do it. This was supposed to be completed by now, but obviously we could not install them. They will be installed by the end of August. And we have basically certified almost all the beam lines in terms of all radiation and all the other constraints. So I want just to say a few things that we really have been striking in terms of all the subsystems that results in a very good uptime. The RF system is extremely reliable, so is basically has a mean time between failure way higher than the previous machine already, and the same for the power supply. And the vacuum is thought the conditioning, since we had this unfortunate stop, could not progress as we want. We have anyway a very good, say, head start, because nevertheless he performs already a factor 2 better than what we theoretically were expecting. So this is the true also for the machine alignment, and this results also in the fact that all the beam lines, they got light right away through their systems, and the beam is really incredible stable. This is thanks to the very good engineering of all the support systems, girders, and all the elements. And for what concerns the optic, we have a tuning that is very close to give us the theoretical design values for all the optical parameters. And again, thanks to all the way of the machine has been tuned, and all the stability of all the systems is extremely stable. So for what concerns the future, so this also we have been working as well, because we don't want just to stop and obviously take full advantage of what we have done so far. We want also further push the limit of the machine. Since this machine has very small beams, we think that we can further improve the performances of the ondulators, and we can also further squeeze the beam inside the ondulators in order to deliver brighter and brighter beam. So in particular, we want to install extra focusing element in particular short section. One is already up to that, and thanks to this we can further increase the brightness and the tunability, the range of the insertion devices, as you can see from the bottom plot. This also is true for all the insertion devices in air. We are also working on producing standard straight section chambers with even smaller gap, and this will allow us to have ondulators, instead of having several ondulators on the same straight section with different periods to cover all the spectral range needed by the users. With just one single device, we can have see this blue line, we can have a higher brightness, even up to a factor 2, and much better coverage through the spectrum. The machine also has a lot of safety margins that we can slowly tack and see how much we can take advantage of these safety margins. And in principle, we can pushing the lattice parameters, we can further reduce the horizontal emittance by about 30%. And in addition to this, we can further increase the lifetime and hopefully further decrease the gaps in the vac ondulators, installing a fourth harmonic cavity that will lengthen the bunch length. So, and with this, I want just to go to the conclusion. I would just say that for us, this machine is really a dream machine, but a machine that now is a real solid machine, and we will gladly deliver these very nice X-ray beams to push forward the research on synchrotron-based X-ray sources. Thank you.
Thank you very much, Pantaleo, for this very nice presentation. And while now you leave the screen to Jean, you should stop sharing. I hope that everybody is following us and enjoying this presentation. And the next one is coming from Jean, which will tell us about the Beamline Restart program.
You are in mute, John.
Again.
On point, unmute. So thank you, Francesco. And as I said, good afternoon, everyone. As a very logical complement of the two former presentations, it's indeed my pleasure to share with you on behalf of all ESRF colleagues some practical information about how Beamline will start and the way we propose to resume the user operation on due time, per se, the 25th of August. So let's start with the timeline, and this timeline is framed with several milestones, the 2nd of March until yesterday, and then the 25th of June, as you know, which is the user mode. Actually, at the end of the long shutdown, we used one day on the 30th of January, and that again was also an emotional day since we had for the first time a direct views on the wide beam viewers we had on the at the ESRF on all beam lines, and we saw for the first time this very nice circular beam, which correspond very much to the different simulation we made. So that was the first beam we saw on the different beam lines, and then we started on the 2nd of March the official restart of this of those beam lines. And actually, as you know, we had this COVID-19 lockdown, which make, in fact, very short the restart. And we started, as expected, at a low current when we made a number of tests and radio protection services at 9 milliamps. While after the lockdown, we were in position to restart all the beamline at 200 milliamps, the nominal operational current. So as you can see on those dates, we had, technically speaking, 2 weeks before the lockdown, and we are 2.5 weeks after the lockdown, which make, in fact, the restart quite short. However, during this period, and with a very strong support from, in particular, from the radio protection colleagues, we were in position to restart 5 beam lines, which are now fully operational, as Francesco said, for COVID-19 research. And we have 25 beam lines out of the 20 original ones, which are now ready for the full scale commissioning. And if you compare what we had a few days ago during the test and the certifications of those beam lines, when we were in position to run only 6 beam lines in parallel, we have today, and I took the picture this morning, which is very similar to what Francesco showed you. We have not only a longer lifetime already, but we have now this very usual screen when we see a number of beam lines running, and also in automatic mode. So we are back to what we used to have in the past. And finally, of course, we are going to keep the initial targets of the 25th of August for the user operation. A few snapshots of what happened during this low current test before the lockdown. This is, for example, the very first beam of this specific two-pole wiggler source. And this is really the first beam where Joël Chavan, expert of this insertion device group, is explaining the shape of this beam. On ID13, it was also quite exciting to see that because of the new symmetry of this undulator peak, and where you see the emittance effect, which is no longer valid on this tail on the right hand side, on the high energy side, and you see that we have now a very symmetric beam. That was confirmed on another beam line on ID27, when again you can see on this wide beam viewers the very nice symmetric and circular beam, a nice set of undulator peaks, and here the 7th harmonic, which corresponds to 33 keVs, but again the symmetry of this peak and the bandwidth is going really to impact the use of pin beam at the ESRF. And finally, as expected, the new very small source has also a direct effect on the focus beam, and without touching anything, the gain on ID27 was pretty spectacular, in particular with the symmetric beam. And today, as on many other beam lines, this spot size will be limited by mirror slope errors, which of course recall us that we have a lot of commissioning and also upgrade of the optical components to be done to take the full advantage of this fantastic source. The next step in our, let's say, roadmap was, of course, to go through the beam time allocation round, what we used to call the 20/2 round. And for that, and for this round, we received 1,238 proposals, plus including the 15 long-term project proposals, which in terms of absolute number of proposals, it's the ranking on the third, but in terms of number of proposals per beam line, it's really a record. And you can see that on the top 10, most of the beam lines are in fact received more than 50 proposals per beam line. So because of the COVID, we had, of course, to revise a little bit the strategy, and the BTAPs, including the 12 committees, met by video conferences. And we are very, very grateful to the 100 plus participants really to have been actively involved in the assessment and the review of those proposals and to propose a ranking. This ranking was quite new compared to the previous years, since we asked the BTAPs to rank the different proposals only on the scientific merit. And why is that? It's because on the 1 month before, in April, we took the decision to start the USM only with remote experiments, and possibly we are going to extend this strategy over the entire run 2022. What does it mean? It means that we are going really to work in remote, which technically speaking means that we have only mailing samples, so that all the experiments will have to be done and performed by the ESRF staff, and we are going to develop a remote connection with the users to really ensure a smooth communication with the users. Why we are doing that? It's because, of course, we have to anticipate possible travel or mobility restrictions, which would be, of course, country and even maybe labs dependence. And of course, we want to ensure a fair access to all members and scientific associates, and not define the access to the beam time over this period, depending on the different restriction or, let's say, freedom to travel. So what are the mitigation decision we took? First was to extend the run of 2020/2 to by 1 month, and now it's going to end on the 28th of March 2021, in order to increase the beamline allocation, anticipating that most of the experiments is going to take a longer time, and we're anticipating an increase of number of shifts per experiments ranging from 25 to 33%. So this extra month is going to compensate for this extra time. What does it mean in practice? In practice, that the strategy will be to start with the simplest experiments and then to increase gradually the complexity at the end of 2020, hoping that we will be better trained, but also we have maybe more support from the users if they can join us at some time. And of course, to schedule with the same spirit the most challenging experiments towards the end of the run in February and March next year. Of course, we have to face a number of issues and challenges which are currently addressed by a number of people. And I'm just listing some of them: the safety, of course, how to handle a large number of new samples delivered at the ESRF by mailing, the logistic, the workload put on the scientific staff performing the different experiments, and of course on the IT and cybersecurity, etc., which will be one of the key points of this new strategy. We have also to revise the selection, the proposal selection procedure by an ad hoc strategy, which is summarized here. We kept, of course, the technical feasibility and the safety assessment as before. The BTAPs change a little bit their habits by considering the scientific merit only. And then we added this layer here, which is an in-depth analysis of the suitability for remote experiment of a given experiment there. And that includes the beamline capabilities, the safety assessment, but also the user consent that, of course, they have to agree to perform their experiments by remote access. And you can also appreciate the challenge, since this kind of assessment is beamline and experiment specific, and it's indeed a lengthy process to select those proposals. And the outcome of this stage, of course, is to have a full proposal selection and the beam time allocations. We committed ourselves, of course, to involve the BTAPs in that and to follow as much as possible the BTAP ranking, but also to keep the BTAPs fully informed about the final decisions. And at the end, of course, to involve the users, which will be kept informed via web pages and dedicated emails. And most importantly, to advise them in due time about possible resubmissions. About the planning until the 25th of August, as you can understand, and as Francesco and Pantaleo recall us, we have to revise the schedule, taking into account the delays occurring because of the lockdown. But we, of course, decided to keep the initial objective, and with two different actions. First one was to re-optimize the time sharing between ISD and experiment division for the different conditioning and commissioning, and that was done very efficiently in the past weeks, but also by maximizing the outcome of the teleworking and remote access, primarily for software and beamline control project. And again, we make, I think, a very good use of the time there. As of today, the revised master plan includes 2 machine shutdown periods in June and August. And from the beamline perspective, we hope to have a completion of the installation of the bending magnet sources, in particular for the CRGs, and having also installation of a couple of insertion devices for public beamlines. At the end, if you sum up the different days of operation for the beamline commissioning, we end up with 4 weeks, 1 week in June and 3 weeks in July, which will be fully dedicated for the control software and implementation of the data policy, but also the integration of the new 2D detectors. We, in fact, have a very ambitious campaign of refurbishment of our portfolio of detectors. We reserved 1 week in July for the CRG beamline startups, which will start at low current at 5 milliamps, ramping up, and then having this formal certification at 200 milliamps to allow us to continue working. And finally, in the meantime, we hope to restart a maximum of infrastructure projects involving new beamlines, involving CRGs, as soon as possible. This is the dashboard which has been produced after a technical assessment of the different beamlines. And as you can see here, we made a sort of beamline readiness assessment for the user mode, for the 25th of August. And using this traffic light color code, you can see that all the beam lines listed here can be either ready for users, this is the green, partially ready or requiring further commissioning, but hoping to be ready by the end of the year, and that is yellow. And the red, in fact, involves beam lines we are, technically speaking, on most of them in constructions. So if you sum up, we have 26 beam lines ready for users by the 25th of August. 11 beam lines will require some commissioning, and 13 won't be ready for users. And as I said, mostly because they are involved in heavy constructions, since they are either upgraded or involved in a new beam lines there. So as the last message, the experimental program, in fact, goes beyond the beam line we start. And as a reminder, we are also pushing for the 4 unique beam lines which are fully optimized for EBS, and the list is given here. We have this EBS L1, 8, 3, and 2, which are now under construction or under design. We are going to pursue the refurbishment program with a long list of beam lines which have to be adapted to this new source. We make the big push on the software side and the data aspects, and together with our ISDD colleagues, we are now pretty well advanced on the 3 different levels of this strategy. The first one is the implementation of the data policy, following the FAIR principle, and we are quite optimistic in saying that we can trust ISDD colleagues to implement this data policy by the end of the year on all beam lines at the SRF. The new beamline control software, which is really a big step also, will be fully implemented on the number of beam lines, and by mid of next year, most of the beamline at the SRF will be equipped with BLIS. And we have a continuous effort about the scientific software library called SILEX, which is continuously improved and made available to the external users. On the hardware side, as Pantaleo said, we are looking forward in seeing the first impact of the new insertion devices associated to small gaps. As I said, we have a very ambitious program of upgrading our 2D detectors, mostly for scattering and imaging. And finally, we are exploring now new access modes to adapt our, let's say, policy to the new capabilities of this EBS source, with a new mailing, and we are pushed because of the COVID, but also a new non-MX bags, etc., etc. And finally, as a conclusion, we are all experiencing a very challenging but exciting time, and all ESRF staff are fully committed to take up this challenge, to catch up, of course, the recent delays, but also to ensure that the main elements of the EBS experimental program will be delivered according to our time. This motivation comes also from the fact that we are believing that the EBS program goes far beyond the realization of an extremely bright source and new beam lines, and aims to foster the development of a completely new context for synchrotron science and innovation for the full benefit of our users and more generally of the synchrotrons community. And with this, there's 2 take-home messages. I thank you very much for your attention.
Now leave the sharing to give the opportunity to Harold to conclude this webinar with a presentation that will let us dream a little bit about what we can hope doing very soon with this new X-ray source. Welcome, Harold.
So yeah, it's my pleasure now to talk a little bit about science and what we actually hope to be able to do with this dream machine, as Pantaleo called it, and hope for many of you it doesn't stay as a dream, it becomes a reality, and we actually see you here to do some science here. Now, what's new with EBS? EBS is the first 4th generation high energy synchrotron radiation source. We believe it will deliver a big step forward for X-ray science. Now, the 2 areas where this machine will be unique for quite a while until more facilities like this will be either upgraded to that level or built or constructed from scratch, is a tremendous increase in coherence in the medium energy range, as you can see here, and there's a large number of beam lines at the ESRF actually exploiting that. and in the high energy range, where the brilliance of the machine will reach levels that were unprecedented before and go even beyond what we were used to have at lower energies. So these are really the two areas where we expect to take full advantage of what this tremendous new brilliance of the machine is delivering here. So Francesco showed this before. So this is a little bit the structure of the science program. We believe that it is important that facilities like this one, where you have thousands of users coming, are actually dealing with real world problems that help solve the big challenges that our societies face today. And Francesco mentioned the UN sustainability goals, the Horizon 2020 program. And from this, we extracted the areas where we think we can have the biggest impact. You see them listed here. There's 7 of them. And I just pick out a few with some examples where I think that the future that we see in the science that we can do here is really bright. So it's in health innovation, and COVID-19 is a perfect example for that. It's all the problems that we have in the energy sector. This is something that was very much on everybody's attention or everybody's list before COVID-19, and of course it will stay there. And of course there's a lot of impact also that we expect to make in other areas that are actually commonly not so much associated with synchrotron, and if you want research that is driven by methods that come from physics. So this is a little bit a picture of where we think future X-ray science is heading. The most important part where we think we can play a major role is that we can help understanding complexity in condensed matter and living matter. So you see this here. When you start with living matter, you start from the molecular level and you go all the way up through the cellular level, the organ level, to a full individual with its body and its multiple functions. You have a similar thing on the material side, where you start with atoms, you start to build larger agglomerates. You actually make this more complex by adding additional functionalities and mixing different materials, and you try to employ them in the best possible way. You have the same thing, the same level of complexity also in natural systems in our environment. And that has always been a strong driver of science at ESRF. So let me start with one example here, down here in the materials area, in the energy area. This is an experiment that was done just before the ESRF shut down with the old machine, using a high energy beam, which I said is a specificity of this facility here, a very small beam that we can make here, or could make here on this beamline, ID15A, for studying a battery cell while it is actually operating. And you can see this here. These are very fast measurements that you do at a speed of 100 measurements per second. And let me just start this here. The way this works is that you actually scan this battery with a very small beam as rapidly as you can, and you see the diffraction patterns on the side, and you study from the diffraction patterns how this material charges and discharges with time. This is time and space resolve. Now imagine with this new machine, we can do this 100 times faster and with much smaller beams, meaning even higher spatial resolution than what we have today. So these are the kind of problems that we want to tackle in the future, that you actually take entire devices and scan them or watch them in full operation and extract all the information you can about their functioning. The same is true for if you go into the biological world. Synchrotron radiation has been making major contributions throughout all generations of machines that we had so far. I told you that this is the 4th generation of storage rings that we are using for this. First generation was actually just basically good enough to look on very large scale structures on the level of skeletal muscles, if you want. We're looking here at muscles. Second generation was actually did already allow us to go into more detail and look into the interior of these muscles. The third generation actually helped us to go much beyond that and look inside these individual sarcomeres, while now with the fourth generation, we now can really span all the range down to the molecular level here. And watching this in the correct hierarchical structure of the muscle tissue, meaning you could actually start with a cell or something like that and go all the way from the molecule to the large scale level. Another example of this is, and this has been done also just before the shutdown of the ESRF, the old ESRF, the third generation source, if you want, where we try to exploit the extremely small beam size and coherence that we already could have at that level. But please keep in mind that what we used at that time was about 5% of the beam. The rest had to be discarded because it was neither coherent enough, nor it could be focused into these very small extreme beam sizes that you need to do this kind of experiments. What you see here is part of a brain, in this case, a Drosophila ventral nerve cord and the mouse cortex. And this is actually a scan, and with holotomography. That's a technique that allows you to achieve full three-dimensional resolution, where you then can extract the connectivity, the connectome of all the nerve cells in this volume of the brain, and actually try from this to understand how the brain actually works, how it is wired, and how individual parts of the brain play together to allow the function that the brain actually has. And there is big projects worldwide that are around in this area, and we have one here at the ESRF, which is actually funded by the European Research Council. That brings me to the last example, where we actually use the extremely high energy that we can produce together with the coherence that we have, up to energies of, in this case, several hundred kilo-electron volts, that will allow us to provide high resolution and a large field of view on objects that are up to meters in size. You can use this either, for instance, for historical objects. Here are images that have been produced with the old machine. On paleontological objects is a 2 million year old human ancestor. Now, if you look at this one here, you will see that this artifact has been partially carved out of its encasing in the rock. Now, with this new machine that we're building here, and the new experiment that we're building here, the location is the bending magnet 18, we will actually be able to scan rocks up to a size of 0.5 meter or even bigger, so that in the future you don't have to carve out these objects anymore and destroy the unique environment in which they are preserved. You can actually take a digital model and cut it out from its original block. Or you can take very complex shapes and objects, for instance, a human being. You could scan it down to the cellular level on this. The key here is that we do this on multiple scales, and we do this from very smallest scales, from the nano world up to macroscopic dimensions. And just to give you a flavor of what's possible with this new machine, this is the first data, the first experimental data that really came out from the EBS. This is on a problem that concerns us all today. As you know, one of the big problems that COVID-19 is causing is lung-related diseases. And what you see here is the best state-of-the-art medical scan of a patient with an advanced COVID-19 disease. So this is essentially this part here, the left side. The right side actually is disease-free, and you see the dramatic changes the disease actually causes. So this image was supplied from the group that is actually doing this experiment at the moment as we speak, where you take either a complete lung or part of a lung, a complete lobe, and this is the real sample here, and you scan that in the beam in its entirety to reveal what the effect of this disease is. This should help, first of all, to deal with the problems that the disease itself is causing, also long-term effects that come from the disease itself. So this is a project that is led by a very large international team, led mostly by German medics, but many other people involved. that also involve other synchrotron sources like the diamond light source, and the whole project is coordinated by Peter Lee from the University College in London. But experiments like this require dozens of people to make this possible. These are very, very difficult experiments. Now I can show you the first images that came out in the last 2 days. Actually, the ones that you're seeing now are partially from last night. So this is really the first multi-scale phase contrast imaging of complete COVID-19 lung lobes from anatomy to 3D histology. So you start with a resolution of about 30 microns. You zoom in, you get something like close to 13 microns. You go one step further, and you get a resolution of about 6 microns. And you go one step further, and you get 2 microns. This is a resolution, as you can see, that has never been achieved before on objects of that size. Now, the new beamline that we're building, BM18, should be able to deliver that on an object the size of a human. So you can see we are expecting great things from this new source, and we hope to see you very soon here at the ESRF to help you realize your most challenging scientific ideas. And with this, I invite you to dream, and I hope that we see you all here, or a large part of you, with your most exciting experiments in the future. So thank you very much for your attention.
Thank you, Harold. This was really a wonderful talk. Now we have many questions that are coming online. I've been watching them through, and I'm very happy to share with, in particular, with my colleague at the ESRF, a lot of congratulations remarks from our users, also our friends, our colleagues. And I just want to underline again that if all this was possible, is in fact, is thanks to everybody. Everybody, not just the ESRF staff that of course had a pivotal role in creating this new machine and these new beamlines, but our member states, all our users with their support, with their ideas and so on. So it's a big thank and it's a big achievement for everybody, and is also a demonstration that indeed all the efforts that are going on today to build other sources based on the EBS concept is something that should go ahead as fast as possible. And so this is also a message to all the different funding agencies in really make all the synchrotron radiation project around the world strong and available soon for our users community worldwide. So with that, I may ask also the help of Delphine in trying to summarize questions. I think there is one recurrent question. I think many users are a little bit anxious by this idea of remote access and the sample mail-in, and they're asking, you know, how long this is going to be maintained, when can we come to do experiment at the ESRF, and so on and so forth. So I don't know if Harold or Jean wants to answer to that question, or to this kind of questions. Allez, Jean.
I can follow up of the presentations. I guess we are trying to adapt to a very specific and contextual, let's say, boundary conditions there, and we have to anticipate, because any new strategy is taking time. We have to, I mean, in terms of logistics, in terms of software implementation and so on. So we decided to anticipate this travel restriction we had, but it's clear that if those restrictions are relaxed, we are more than delighted to change the strategy. So we want to start, and the best way to develop ESRF and to demonstrate the capacities offered, or the new capabilities offered by the EBS source, is to start with USM, to start to do real science at all levels with users, with the in-house research. And for that, we decided to put in place this remote control that we know very, very well for the structural biology community. I just recall that ESRF had the very first beamline, which is really fully remote controlled. But of course, the extension of this strategy on the non-MX techniques is very challenging. We don't aim to reach the same level of sophistication, but at least we hope that in the coming months we can put in place the tools which will allow a very smooth communication with users first, and to have the capacity to perform some experiments. Those experiments, of course, will be biased towards data collection first, and then we are going to increase incrementally the complexity of those experiments by maybe accepting some in operando experiments if the sample environment is simple and can be sent by let's say delivery companies. But it's very clear that nobody has a crystal ball, but we will do our best to make the best use of the experiments and accept users as soon as we can.
Thank you, Jean. There were also questions to Pantaleo about horizontal emittance. So people is asking when are we going to see on the screen values below 150 picometers?
Yes, actually, I did also reply I typed the reply. So, and definitely this is going to be soon. At the moment, at low current, the emittance is very close to the theoretical one, within probably less than 5% from the target value that is 133 picometer. And we are still trying to calibrate and cross-check the measurements with even with the beam lines, actually, to get the more accurate numbers. And anyway, at high current, there is about a 10% increase, mostly due to the fact that the machine still is not fully conditioned. And this, again, will tail off most likely by the start of the USM operation.
I have seen other questions that have to, that again are related to remote access and to the fact that the beamline staff may be quite a bit under pressure in the next 6 months. And there is some anxiety in protecting the ability of in-house research from scientists. So maybe the directors of research again want to answer that question.
But again, I can start, and if Harald wants to complement. Of course, the in-house research is protected for several reasons, because it's one of the drivers, and it's fully acknowledged as one of the drivers of the innovation at the ESRF, and it's something we really want to protect. It's also the best context for the training. I just also remind you that we had to hire more than 100 postdocs, new scientists at the ESRF, and it was not easy during this COVID context. But again, we have to train them, and the in-house research will be part of this training ground. And we can also acknowledge that it's a lot of work and a lot of pressure on the beamline staff, leading to and performing experiments, training new staff and so on, but it's something we have to accept. And again, by respecting all the safety regulations, we hope to be in position to perform the different tasks in parallel, and to speed up the process of commissioning, training, and USM. But I'm sure that Harald can complement if you wish.
Well, you already said it. The most important thing is that we have a quite significant part of our in-house research is performed by PhD students, and the PhD students have always been protected. They are not supposed to do user service. They're here to do research. So this part is entirely protected. We're not using PhD students to do user service. The user service is done by professionals at the ESRF. And the strategy to go from simple experiments to complex experiments will allow us to adapt as we go along, and keep enough capacity in our in-house staff complement so that they can still follow their own in-house research. So this is, I think, this is a major concern for us. We're fully aware of it, and we will protect it.
I can also perhaps contribute to this discussion about this issue about remote access and mail-in experiment. Of course, there are questions like, can in operando experiment be carried out, and so on and so forth. So let me also put this into a more logistic aspect, in a sense that unfortunately, the COVID-19 pandemic is not yet overcome. There are good signs that things will go better, but we are still facing in many, many countries, including France, a situation which is not at all back to normal. So already at the ESRF, like I imagine in many of your labs, we have to use all a series of procedures to work together in a different way, to protect each other from possible spread of the virus, and to protect the whole ESRF environment that so far has been kept COVID-19 free. By the middle of June, meaning in the next 2 weeks, we need to inform all the users that submitted their proposals by the 1st of March deadline about the outcome. And this is the overarching reason that, you know, in the moment in which we inform the user, we also have to tell the user what's going to happen. And today, and let's say until the middle of July, I'm afraid, we will not be in a position to see exactly how the situation will be in September, or October, or November. And there are many hypotheses going on. So we need to inform the users in a way that then we can, to the best of our knowledge and capacity, sustain. And that's where the remote access has become a really, you know, reference argument, because it's not, in many cases, not only depending only on the ESRF, but also on all the travel restrictions that may apply into the users' lab, into the countries from which the users are coming from, and so on and so forth. So that's why, indeed, we will give a priority to those experiments that have a very high scientific value, but at the same time are reasonably simple to carry out. Let's all hope that the situation will evolve into a positive outcome, and maybe, you know, in the middle of the middle of the fall, beginning of the winter, the situation will be a little bit more under control, so that we could envision people coming back, users coming back to the ESRF. I mean, it's clear that we don't want to change our reference model. And so just bear with us and understand that, you know, our purpose is really to make sure that a maximum scientific outcome is going to come from the use of the new source. There was also a question about industrial access. Indeed, industrial access for us is very, very important. We want to restart it as soon as possible, and the business development office and the team working in it is ready to assist all of those that wish to restart industrial activity at the ESRF. And we plan to restart industrial access to our beamlines also as soon as possible, and possibly with the remote access conditions as well. So don't be afraid that this is also in the list of things that we want to do, and please establish as soon as possible again a contact with the ESRF Beamline Development Office and with Ed Mitchell. So
there's a last question on the when do you plan to communicate the accepted proposal for the first round?
As I said, it should be in the middle of June, around the 15th of June, correct, Harold and Jean?
Yes, what we do is a beamline-based assessment. Obviously, when you say that you check experiments for suitability for mail-in and remote access, you have to do this beamline by beamline because the beamlines are vastly different. And this takes a minimum amount of time to go through this. But we hope to be ready with the first wave of acceptance messages by the middle of this month.
Okay, I also wish to inform that these topics has been discussed at length with our Science Advisory Committee just last week. And again, some provisions will be made to inform clearly those proposals that have been postponed because of their feasibility in the context of COVID-19, but which got a very high scoring. And the invitation will be to resubmit under specific conditions, which are being finalized. So all this information will go out also in preparation of the next deadline, which is the 1st of March, or 10th of September of 2020, 10th of September 2020, yes. To go to another argument before closing, there was also some questions about, Jean mentioned the ID27 beamline and how easy it was to get a 2.1 times 2.7 microns focus. And the question was, how many photons more can you put in that spot as compared to the situation before on ID27?
Maybe I should answer that question. The ID27 beamline is currently being reconstructed. It's one of the beamlines that are completely refurbished. And the flux increase that we expect in a beam that is significantly smaller than it was before, is less than 1 micron by 1 micron, is a factor of 100 in monochromatic and a factor of 5,000 in pink beam.
So a big challenge also to not to break diamonds because you are going to the multi-megabar regime, but because you may have some heating up problems with this beam. But we will see.
But as a general observation during this low current test, it was interesting that most of the beamline measure almost the same flux at 9 milliamps than at 200 milliamps with the old machine. So without any optimization, you can already feel the gain in flux, not in brightness, but in flux between the two sources.
Another final question, thanks, John. Another final question is about the slides of these 4 presentations. We will put the slides on our website, but also the presentation is going to be on YouTube, so you can see it again. And perhaps from those slides, in particular from the one of Harold, some will be taken off because, as you can imagine, some of the data that were taken up last night are unpublished, and therefore we don't want to put them, in the general public without the consent of the scientists that for which we took those data. So, Delphine, do you think we have other issues that we want?
We have covered all the questions, yes.
Okay, so with that, I think we can finish this webinar now. I thank you very, very much for your attention, and for staying with us and for taking the time to link. And we all look forward to welcome you here at the ESRF. There's not be any inauguration yet, any moment of fun and relax to share together this new tool for science, and let's hope that this will happen and that the whole humanity will be able to overcome this unexpected and very tragic circumstance that has already taken up so many lives. So again, all my thought goes to those that have lost some dear person, and my big thanks and the thanks of all ESRF staff to all those that are engaged in overcoming these pandemics. And with that, I thank you for all, and I wish you all the best for the coming months. Thank you.
Thank you.